Hello everyone, I am Purnima Subramanya Bhatt. I am studying in 3rd semester CSE Data Science Department. Today's my course is Mathematics for CSE Stream 3. The code is BCS 301. Today's my topic is exponential distribution. We will move on to the first slide, that is exponential distribution, and then introduction to exponential distribution. In that, exponential distribution is a continuous probability distribution. It's a commonly used to model the time until an event occurs, such as a failure rates. The distribution has a single parameter, usually denoted as a lambda, which is the rate parameter. In this picture, we can see that exponential distribution formulas, that is f of x is equal to lambda into e to the power of minus lambda into x, and another formula is f of x greater than small x, which is equal to the e to the power of minus lambda to the power of x, and then another formula is f of x less than x is equal to the lambda to the power of e to the power of minus lambda into x. And then we will move on to the next slide. That is characteristics of the exponential distribution. The exponential distribution is a memoryless, meaning the future is independent of the past. Its probability density function, that is PDF, which is given by f of x is to lambda, which is equal to the lambda into e to the power of minus lambda into x for x greater than or equal to 0. The mean and the standard deviation of the distributions are both equal to 1 by lambda. And then the properties of the exponential distribution. Minimum of the two exponentials, that is if x1, x2, which is up to xn, are the independent exponential where x into n has the parameter rate, and then minimum of the x1 to the x to the power of n is exponential with a parameter rate, that is L1 plus N2 up to Ln. Computing exponential, which are independent exponential with the parameters rate L1 and L2 respectively, and then P of x1, which is less than x2, which is equal to the L1 into the L1 plus L2, that is probability x1 occurs before the x2 is L1 divided by L1 plus L2. And then the application of the exponential distribution. Exponential distribution is often used in the reliability engineering to model time until the failure. It is applicable in the queuing theory, such as the service time in a queue. It is also used in the various fields including the telecommunications and the survival analysis. In this picture we can see that the example, that is bacteria exponential growth. Once bacteria and the mold start growing on the food that is not refrigerated, it reaches harmful level is very quickly. This is the graph which is behind it. And then the relationship between the other distributions. The exponential distribution is a special case of the gamma distribution. It is also related to the Poisson process, where the time between the events follows an exponential distribution. The exponential distribution can be used to derive the other distributions, such as the Erlang distribution. And then we will move on to the next slide, that is cumulative distribution function, that is CDF. The cumulative distribution function of the exponential distribution is given by f of x is to lambda, that is equal to the 1 minus e to the power of minus lambda into x. The CDF represents the probability that a random variable x is less than or equal to x, and then it's a non-decreasing function and approaches 1 as a x increases. And then we will move on to the next slide, that is the hazardous function. The hazardous function or the failure rate for the exponential distribution is a constant over time. It is defined as h of x is equal to f of x divided by 1 minus f of x, resulting in the h of x is equal to lambda for the exponential case. This property highlights the memoryless nature of the distribution as the risk remains constant. In this picture, we can see that the formulas for the hazardous function in the exponential distribution, that are h of t is equal to df of t divided by dt into 1 divided by s of t, which is given by h of t is equal to f of t divided by s of t. And then we will move on to the next slide, that is a parameter estimation. The maximum likelihood estimation MLE method is commonly used to estimate the parameter lambda given as a sample of n distributions. The mile for the lambda is calculated as lambda is equal to lambda divided by summation of x minus I, and then confidence intervals can also be constructed to access the uncertainty in the estimate of the lambda. And then we will move on to the next slide, that is the limitations of the exponential distribution. In that, the assumptions of a constant hazard rate may not hold for all the real world scenarios. It can be model systems with the increasing or the decreasing failure rates effectively. Alternate models like the Weibull and the normal distributions may be more suitable in the complex cases. For example, the amount of the time until an earthquake occurs has an exponential distribution. In this picture, we can see that inverse square decreases. The volume of the sound increases in a 1 by distance x distance, or 1 divided by d square or the d to the power of minus 2 relationship. Move 4 times further away and the sound level is only 1 divided by 16th of the what it was. Sound dies off quickly as we move away from a loud party or the car, but takes a while to drop down the complete silence. This is the example for the limitations of the exponential distribution. And then we will move on to the last part, that is a conclusion. The exponential distribution is a fundamental concept in the statistics and the probability. Its simplicity and the unique properties make it valuable for the modeling time-related phenomena. Understanding its applications and the limitations is crucial for the effective data analysis and the modeling. This presentation provides a comprehensive overview of the exponential distribution, covering its definition, characteristics, applications, and the more. In this picture, we can see that which are the key points for the exponential distributions that are most used in the distribution in the reliability. Can be used when the item has survived the early failure phase and has not reached the wear out phase, that is the during constant failure phase. The formula for the exponential distribution is R of t is equal to the e to the power of minus t divided by mtbf, which is equal to e to the power of minus lambda into t. Thank you guys. Please do like and share.